Hi everyone, so this is our sets part 2 video. So the first thing we're going to look at in this video is finite and infinite set. Now, a finite set is a set that has an end, meaning you can list all the members of the set, right? It has an end. An infinite set is a set that does not have an end, meaning you cannot list all the members. So let's look at some examples of the finite and infinite sets. So a finite set, as we said, is a set that has an end. So meaning set A is equal to the even numbers from 11 to 20. So we can list out all the members of that, right? That'll be 12, 14, 16, 18, 20. So we can list all the members of set A, therefore it is a finite set. Now, infinite set does not have an end. Think about the word infinity. Infinity means it goes on and on and on and on, has no end, right? So, for example, if I want to list the multiples of 5, so we could start off saying 5, 10, 15, 20, 25, 30. You could write 35, 40, 45, but yeah, it keeps on going on and on. There's no end. So we put the 3 little dots just to represent that it goes on and on. There's no end, right? So infinite set does not have an end. Finite set has an end, so you can list all the members, right? Now let's look at a null or an empty set. Now, null means empty, right? Means nothing, right? A null or empty set is a set that has no members or elements. The symbol used to represent a null or empty set, O with a slash, well, the slash should be in the middle, right? And my slash is still not going in the middle, but they get the hang of it, right? So empty, or we could have two curly brackets with nothing inside it. So that's a null or empty set. So for example, let Z equal to a set of squares with 5 sides. Now, Z is an empty set because there's no square with 5 sides. All squares have 4 sides. So therefore, we write Z is equal to the empty set, or we could write it set Z is equal to the empty set using the 2 curly brackets. Let's look at the example here where we kind of combine finite, infinite, and null sets. So number 1, J is a set of even numbers less than 100. So even numbers less than 100, we can list out that. So that's finite. That's a finite set. Let's look at number 2. S is a set of odd numbers. Now, odd numbers are what? 1, 3, 5, 7, 9, 11, 13, 15. It goes on and on and on and on and on. Therefore, there's no end. So, number 3, D is a set of people with 6 legs. Now, there's no one with 6 legs, so therefore, this is a null set. You can write null or empty, right? And then number 4, A is a set 2, 3, 5, 7, 11, 13, 17, dot, dot, dot. And that dot, dot, dot lets us know that it goes on and on. So this is an infinite set, right? It doesn't have an end. So far, so good. Now we're going to look at equal sets and equivalent sets. So, consider the sets. We'll look at equal sets first. Consider the sets M. M is equal to 1, 2, 3, 4. And set N is equal to 3, 4, 1, 2. Now, both sets have 4 members. I have 1, 2, 3, 4 members in set M, and N has 1, 2, 3, 4 members. So both sets have 4 members. Now, they also have the same members. In set M, I have 1, 2, 3, 4. Set N, I have 3, 4, 1, 2. That is the same as 1, 2, 3, 4, just in a different order. Therefore, set M and set N are equal sets. Why? Because they have the same number of members, and they have the same members, just in a different order. So equal sets meaning everything is the same. Everything is equal, right? Order doesn't matter. Now, let's look at equivalent sets. So consider the sets A is equal to 1, 2, 3, 4. And B is equal to, set B is equal to P, Q, R, S. Now, both sets have the same number of members. A has 1, 2, 3, 4 members. And B has 1, 2, 3, 4 members as well. So they both have 4 members. But they have the members are different, but they have the same members. Once you have 2 sets and they have the same number of elements or same number of members, they are equivalent sets, right? For sets to be equivalent to each other, they must simply have the same number of members. So something to note there. So now we just have a simple exercise. State whether the following sets are equal or equivalent. Let's look at number 1. So number 1, set D, we have 2, 4, 6, 8. Set A, we have 6, 8, 2, 4. Now, both sets have 1, 2, 3, 4. 1, 2, 3, 4. They both have 4 members. And they also have the same members, just that in set A, we have it in a different order. So therefore, these are equal sets. Same members, same number of members as well, right? Equal sets. Number 2, set X is equal to A, B, C, D, and set Y is equal to 2, 4, 6, 8. Set X has 1, 2, 3, 4 members. Set Y has 1, 2, 3, 4 members as well. So they have the same number of members, same number of elements, but they are different. Therefore, they are equivalent. And number 3, B is equal to set B is equal to A, E, I, O, U, and L is equal to E, I, O, U. Now, set B has 1, 2, 3, 4, 5 members. Set L has 1, 2, 3, 4 members. That already tells you that there is neither equal, so neither equal or equivalent. Right? And so in this video, we really went through the different types of sets, right? Finite set, infinite set, null or empty set, equal and equivalent sets. They're not hard. It's just good to just keep on going it over to remember what means what. But it's kind of some of the words give off the answer, like infinite, infinity, no end. Equal, when something is equal, it had to be same, right? And null or empty, well, there's nothing in it, right? So just keep that in mind.